Hey there, everybody. Welcome back. We're actually a little ahead of the game at this point. Um, chapter 4, I had scheduled to take 2 weeks working on, so we would have been finishing up Chapter 4 this week. But in fact, we finished out Chapter 4 last week. So rather than diving right into Chapter 5 right now, I thought that I would just take some time to practice fleshing out a program using pseudocode first, and then diving into actually writing the program. So what we're going to do today is we're going to develop a program that will allow the user to input what the current temperature is in either Fahrenheit or Celsius, and then convert it to the other one. So the first thing that we need to do is we need to write our pseudocode so that we can prepare to actually program this. So let's go ahead and get started on the pseudocode. I've got a new text document open here, and I'm going to go ahead and I'll be using this same document to write my program. So I'll put my initial comments up above. And I misspelled temperature. That is a fantastic start to the day, isn't it? Converts current temperature to from, well, we'll say from Fahrenheit to Celsius and vice versa. Okay, so the first thing that we will have to do in our program will be to set up the program with our include files and variables. And we'll just make a note here of what include files we know that we need. We'll need to include IOStream. We will need a variable to get the temperature from the user. We will also need a variable, and actually we'll need this before we need the temperature. We'll need a variable that will allow us to get a choice. And then we'll need a variable for the converted temperature. Okay, that's probably all that we will need. We may add more to this as we go along. As we start off our program, we'll also actually need a variable to determine whether or not they're going to play again or continue converting. So we'll just say that we will need a variable that will ask if they want to run the program again. Okay, so the first step when our program runs is we want to introduce the program and give the user a little bit of instructions as to what they need to do. And then what we'll do is we'll have what we referred to before as a game loop. This time it's not going to be a game, it's a program loop. So while the user wants to continue converting, okay, as long as the user wants to continue, we'll run through our different options and convert the program. So the first thing that we will want to do is ask them if they want to enter their temperature in Fahrenheit or Celsius. Okay, so we'll ask them what they want to enter the temperature in, and then we will get their response, or we'll just say that we'll put their response in the variable choice. Now, if the user chooses to enter the temperature in Fahrenheit, we'll ask them what the temperature is, and we'll store that value in our temperature variable, whatever we eventually name that. And then we will convert it. To Celsius. And then we will display the result. If they don't choose F, we will ask them for the current temp. We'll store the temp in a variable. We'll convert the temp. And display the result. After that, we will ask if they want to check another value or another temperature. And if they say yes, well, let's see. First, we need to actually store their response. Okay, now if again, excuse me, if again is yes, then we will set how do we want to do this? We want to set a variable. We'll just say, we'll call it success. Actually, no, we'll set quit to no. Otherwise, set quit to yes. And that will actually end our while loop. If, at this point, if they say that quit is no, we will rerun the loop. If quit is yes, we'll end up exiting the loop. And we don't have to use a break statement here, it will automatically do it. I'm going to change in my pseudocode up here. I will say that while the user does not want to quit, we'll run all of this. Okay, and when the loop exits, we'll tell the user goodbye and shut down the program. Okay, so that I think that does a pretty good job of fleshing things out. Now we can go back up here and we can start actually writing our program. I'll comment that out. Okay, so we want to include IOStream. So I'll change this to an actual include. That may be the only include that I have for right now. I do expect that I will add one more to that, but I'm going to wait on that until we have our program run and you see what the output looks like. To save myself some typing, I'll say that I'm using namespace std, and this is probably a good time to go ahead and save my document. So I will save it in week 7, and we will call this temp conversion.cpp. Okay. Next, we need to start setting up our variables. Okay. Variables that we've identified. We need a variable to store their choice, and that will be a C or an F. So we'll call that a car. So we have a variable car choice. And instead of ask if run again, we're going to ask them if they want to quit. And that will be a yes, no. So that's also a car. And we'll go ahead and set that to no right off the bat. So that when we run our program, our loop will run, because our loop will test while quit is not true. While quit is not equal to yes, is what I'll probably do there. And so I have my semicolon. Okay, temperature. This is going to be an integer. So I'll just shorten this to temp. And my converted temperature, actually, let's make our temperature a float, just in case they're entering decimal values. Next, we'll have float for a converted temp. And I did neglect to open my main function, so we'll go ahead and do that. Up above there. Now we're ready to go ahead and introduce the program and give the user some instructions. So we do that using cout. Remember, anytime you want to output to the console, you use cout. Okay, so I'll just give some introductory comments. Tell them that they can convert a temperature between Fahrenheit and Celsius. Okay, next we have our program loop. That's while the user does not want to quit. So we'll have while quit is not equal, well, we'll just say while quit is equal to yes. Next is to ask the user if they want to enter their temperature in Fahrenheit or Celsius. And we'll say, would you like to enter the temperature in Fahrenheit or Celsius? We're not putting a new line here because we're going to go ahead and have the prompt right there. We do want to direct them how to enter their response. Okay, so we put an F/C in parentheses. That is kind of a standard way of letting the user know what their choices are. Okay, then we want to put their response to that in the variable choice. And we do that using cin. Okay, again, anytime you want to pull in data, you use cin. If you're just pulling in a single word or a single character. If you are pulling in a sentence, cin will not work for you. It will only accept the first word. After that, it will not work. There is a way around that. There's another command you can use that we'll talk about a little bit later. Okay, so we've got their choice. And so if they chose F, so if choice equals F, we ask them for the current temperature. And you can see we've done a lot of our typing already. Okay, we ask them what is the current temperature, and then we will store that value in our temp variable. And next we want to convert the temperature. I'll add in a comment up here. And next we will be converting the temperature to Celsius. Okay, so how do we do that? Well, okay, we have our converted temp variable. So we take converted temp, and that is equal to temp. Now we need to know what is the formula to convert from Fahrenheit to Celsius. I can actually find that through Google. Okay, formula to convert C to F. And math.about.com gives us the actual formula. Okay, so Fahrenheit, Celsius is equal to 5 divided by 9 times F minus 32. Okay, another way to write that is in parentheses the Fahrenheit temperature minus 32 multiplied by 5/9. Okay, I believe yeah, this is a slightly easier way to read it. So there's our formula. The temperature in Fahrenheit minus 32 times 5/9. So how do we do that here? Well, we have our temperature, minus 32 times 5 divided by 9. Now, because we know our order of operations, we know that like this, the multiplication and division will get done first, and that will not give us the correct value. So we need to put temp minus 32 in parentheses. That way we will subtract 32 from our current temperature first, then we'll multiply it by 5/9. Okay? That's our conversion. Next, we want to display the result. So, we have Cout, and then we say that the current temperature in Celsius, well, we'll just say the current temperature is, I have to close my quotation marks. Current temperature is converted temp, and we'll have the C period, and then we'll have 2 line returns. Okay, that takes care of converting from Fahrenheit to Celsius. If they choose Celsius, we have our else, and once again we're going to ask them for the current temperature. This time in Celsius. And we'll store that in our temp variable. Now we'll convert the temperature to Fahrenheit. And we use our converted temp equals. Okay, so now we need to know what the formula is to convert from Celsius to Fahrenheit. And this web page gives us that. The temperature in Celsius times 9 divided by 5 plus 32. So converted temp equals temp times 9 divided by 5 plus 32. Okay, once that's done, we'll go ahead and display the result. We'll have a Cout. The current temperature is converted temp F and that ends our if-else loop. Okay, now we've gone through one cycle. We've asked if they want Fahrenheit or Celsius, and we've converted the temperature for them. Now, maybe they want to also convert the temperature in another city, so we ask if they want to check another temperature. We give them their possible choices, yes or no. actually, rather than asking them, do they want to check another temperature, since we're asking them if they want to quit, we'll say, would you like to quit now? And we will put that value in our variable quit. And that ends our while loop. If they put yes here, it'll exit the loop. If they put no, it will continue the loop. I did make a mistake back on line 23. I put while quit equals yes. If I had put while quit equals yes, the loop would have never run. Because we're asking, do they want to quit? If they say no, we run the loop. If they say yes, we exit the loop. Okay, so at the end of the loop, we want to, at the end of the program, we want to tell the user goodbye. And I've got my operators wrong there. So we tell them goodbye, and then shut down is return 0. And that's the end of our main function. It's also the end of our program. So let's see what mistakes I made. Invalid conversion from const character to character on line 14. Okay, I'm back, and I figured out why we were having problems compiling here. I didn't realize that in C++, it actually matters whether you use single quotes or double quotes. If you are defining a car, it expects that to be in single quotes, and if it is not in single quotes, it thinks it's a constant instead of a variable. So what I have done is on line 14 of my code, I've changed my double quotes to single quotes, or you may just know it as the apostrophe. The same thing on line 23 in my while statement, and on line 28 in my if choice equals statement. Okay, once I did that, you can see that I can compile my code without any errors. And so we'll go ahead and run it. It asks, do I want to enter the temperature in Fahrenheit or Celsius? Now, here's the gotcha. If I just put the letter F, it asks for the current temperature, and it says that the current temperature is 113 degrees. Okay, do you know why that is? I entered a lowercase f instead of an uppercase. Now, I'll do the same thing, but this time, oh, I said that I wanted to quit. Okay, we'll run it again. I'll put a capital F. What's the current temperature? I'll call it 45. And now it says the current temperature is 7.22222. Okay, so that's more accurate. Now we see what happens if we enter our temperature in, or if we enter our choice in a lowercase letter when the program is expecting an uppercase. That can be a problem. There is a way to work around that, and we will see that in a moment. It asks, do we want to quit now? We'll say no. Do we want to enter another temperature? We'll say yes, this time in C. And we'll call it 37.1. And it says that the temperature is 98.78. Would you like to quit now? Yes. All right. So now there are two things we want to fix here. One, we want to allow them to enter either a lowercase or an uppercase letter here. And we also want to allow them, we want to limit how many decimal points it returns. Okay. What we'll do, first of all, we'll fix the problem of the uppercase versus lowercase first. So to convert from lowercase to uppercase, we use a function called toUpper. So what we're going to do here is we're going to change choice to be equal to choice.toUpper. And let's see if I remember that correctly. G++. And toUpper is in the standard namespace. It's in IOStream. So we shouldn't need to include anything else. Request remember toUpper in choice, which is of non-class type car. Well, that should have worked. So we'll just do a little Google. Find out what we might have missed. Oh, I've got a feeling. Aha! There's another file that we need to include. Up here in our include, we'll include CC type. And we beach ball for a little while. There we go. And it is all lowercase toUpper. And actually the format for this method is toUpper and then our variable. Save it and try this again. There we go. Now we'll run our program and see what happens. This time I'm going to say in a lowercase f that I want Fahrenheit. I'll say 45. Okay, exactly what we wanted. Now, the next thing that we want to do is we want to limit these decimal points. Okay, we do that using another function called floorF. FloorF will limit the number of decimal points returned by a conversion. FloorF is in the CMath header file, so we need to include CMath. And after we do our conversion, actually we can just do this here. We can say the current temperature is floorF, our converted temperature times 100. And that will give us a limited number of decimal points. We'll do the same thing here. floorF, converted temp times 100. And save, compile, and we'll run it. Okay, so we'll say we want to enter the temperature in Fahrenheit. Temperature's 45. That's not right. It says that it's 722 degrees Celsius. And no, it most certainly is not. And no, it is not 722 degrees Celsius. What's happened here is we've had a floor which strips out some of the decimal points. It limits the number of digits that floor temperature can return. We've multiplied it by 100. Now, to get our 2 decimal points back, we need to divide by 100. Okay, so I change that. I add divide by 100 after my parentheses. And I'll compile. Run. Fahrenheit 45. 7.22 Celsius. No, I don't want to quit. We'll say the temperature is 2. And that's 35.59 Fahrenheit. This time we'll go ahead and quit. Okay, so some new commands here. We had our toUpper, which allows us to take any value, or any character in this case, and if it's in lowercase, it will automatically put it in uppercase. Now there is also, along with that, another one called toLower. So let's say someone types in a capital Y to quit, and the program will not quit. We'll see that here. We'll run it. Fahrenheit 35. Type a capital Y. Oh, that time it actually did work. And oh, well, because we're testing for is quit now equal to no. All right, so let's say Fahrenheit 35. They put a capital N, and it quits. That is not unexpected behavior. They would expect the program to continue. So we need to allow for that by converting this to lowercase if they type it in uppercase. So we will now take our quit now variable, and we will set that equal to toLower quit now. Okay, we'll save that and compile it. Run it. And I'm going to put my caps lock key on. Let's say I'm one of those computer users that always has their caps lock key on, so they're always shouting at you in their emails. So we want to enter in Fahrenheit. We'll say it's 37. And do we want to quit? No, we don't want to quit. We want to keep going. This time, it works as expected. Okay, so toUpper, toLower, those have the effect of changing the case of your particular character. The other one that we learned was floor F. Technical definition of floor F. This is a math function that rounds to the largest integral value not greater than x. We didn't specify x. We just said floor F. So it rounds to the largest integer. So what that does here is it takes this returned value, which would have been, let's say it would have been 2.77777777, and it rounds it to the nearest integral value times 100. So we've taken our temperature, multiplied it by 100, which would make 2.77777777 be 277.77777. Rounds it to the nearest integer, 277. And then, outside of the floor F, we divide by 100. That puts us back to our 2 decimal points It's a convoluted way to limit the number of decimal points your float returns, but it is the least complicated way to do it. There are more complicated ways to do this, but basically floor F, and then you multiply floor F by your value times 100. That will strip out the decimal points, but leave you 2 digits extra. That way, when you divide by 100, you have 2 decimal points. If you wanted different values, if you wanted 3 decimal points, you can adjust this in order to allow for 3 decimal points. You would have to figure out the math for that. I'm not going to tell you because that's going to be extra credit. Okay, so that covers floor F, CN, or not CN, floor F, 2 upper, 2 lower. You see how to really implement these order of operations and arithmetic in order to do conversions. I'm going to be posting a couple of extra credit opportunities. You're welcome to do as many of these as you want. And if you have any questions or problems, just let me know. Thanks a lot, guys, and have a great week. I will be in the office 6 to 8, Tuesday and Thursday. Well, probably 6 to 7. So if you need to see me, come on in. Talk to you later.